Hi, welcome back to Python programming from beginner to programmer. Today we are very excited to discuss this very powerful and interesting mechanism in Python and in programming languages in general. And that concept is called function, and also an associated concept called lambda. Now, what are functions? Why do we need it? How do we use it? What aspect of writing a function should we be paying attention to? What are the details of constructing a function so that it is useful? How do we make it useful? And so on and so forth. There are a lot of questions about it, especially when you, the beginner, are coming towards programming concepts new. So there will be a kind of a jump in terms of conceptual understanding, but I assure you it's nothing very mysterious because it all boils out from the need to achieve certain goals. Goals like clarity in the logic, reusability to save time and increase productivity, and also to ensure that when your code and logic are clearly readable and clearly specified, understandable by all programmers in the team or in the world, you tend to make less bugs. And when you make less bugs, there'll be less disaster down the line. There'll be less need to revisit your program and work out the bugs, and therefore more productive, and so on and so forth. So there is a slew of a lot of advantages when we can use functions cleverly and appropriately so that we will be able to achieve all the goals that we just talked about. Yeah. Now, we'll start by understanding the purpose, because if the purpose is not clear, one can actually write a very complex function, no, sorry, a very complex application development linearly, just write out all instructions and repeat throughout and all that. And it's very hard to maintain, hard to change, hard to upgrade, hard to do many nice stuff. All right, so we want to understand the goal first. Then for the next few bullet points, we're actually plowing through the functions components and understanding how what roles they play and what are the kind of side effects they might have, and what other aspects we might have to pay attention to. And finally, we come to the last bullet point where we have this special category of functions called nameless functions, meaning, well, that the rest of the functions are named. So the nameless function is essentially our lambda, but we'll get to that in a while. So before we begin, we will, or rather I will, like you to run your spider, but as in all sessions, because this whole sequence of videos that I'm trying to create is meant for hands-on learning, to go along with me, make some mistakes along the way, and then understand why the mistakes were made and how to correct it so that you don't do the same in future, and so on. So it's more like a lab following kind of session. So please do not sit back. But for now, let me just demonstrate to you why we need to use functions. Because for programmers like yourselves, or rather beginners like yourselves, coming new towards the concepts of programming, there's a question of why do we need more and more of such complicated mechanisms for us to study, for us to learn, for us to take exam? No, not really. Let's just take a real example, for example, for discussion's sake. So suppose your boss asks you to add up 1 plus 1 plus 1 plus 1 plus 1 10 times. All right, maybe using Python, right? If you don't use Python, I will not hire you anymore. So if that's the situation, how would you proceed using what we have learned? Now we have talked about sequence, uh, conditionals and loops and jumps, all the different control logic present and supported in Python. So how do we go about adding ones 10 times? Now I'm of course giving you one adding for 10 times, and if you were to tell me I use my brain and so it's 10, that's not the question, because the point here is that the boss will ask you to add 100,000 rows of ones because the ones are the data being captured by field input technicians or nurses in the COVID-19 test stations, for example. And so all the ones are being streamed in to your central server, and you're supposed to write a Python script to add them all up. Okay, so let's just, for simplicity, assume it's all ones. Complicated cases that can be 1, 3, 5, 9, and whatever. So if you were to add up all the ones 10 times, in Python, we could say something like x equals to 1 plus 1 plus 1 plus 1. I know some of you are like smiling away because obviously this defeats, I'm just counting if I get all 10 correctly, this defeats the whole purpose of programming, because we are supposed to be saving time and not trying to use as in a proportionate manner, use as much time as the size of the data to be computed. That's insane, right? Because if you're dealing with big data, gigabytes, terabytes, petabytes of data, it means we have to spend gigaseconds, teraseconds, and petaseconds. That's insane, right? That's not going to get us anyway. Anyways, using what we have learned so far, that's what we can do. So if we do a print x and run it, clearly everyone should expect that we see the answer. Yeah. So this could have been 1 million, right? So just try to imagine the magnitude of this problem. Even though I'm giving you 10, it could be 10 billion ones to add up. All right. Now, some of you might be suggesting, well, we learned looped as well, right? So we could have used a loop. Let's say it's a for loop, because we know upfront there's a finite number of times to loop over. And we can say total equals to 0 at first. Yeah. And for I in range 10, every time we loop through, we will add 1 to the total, right? So in this case, when we print total, not surprisingly, we would have added 10 times of ones to total, and we can get 10 again. The second 10 is by the loop, and the first 10 is by the printx. So far, so good. Then we would have avoided any need for function, right? And yes, but your boss is very excited, says, excellent. I've asked you to add up 100,000 ones and you did it in a split second. Marvelous. How about now, I am going to upgrade our programs and I'm going to send in 100,000s of twos, for that matter, just for illustration, add up 10 twos. Well, of course, that's 10 times 2, that's going to be 20. But we're not going to repeat this one and then change all the ones to 2. We're going to probably repeat the second one, the loop, the second attempt. And let me just comment out the first version. That's not useful, that's ugly, that's not repeatable. And we're going to copy and paste. And now we can very systematically and very accurately change exactly that spot to support our new objective of adding 2's 10 times. So when we run it, we'll see the first 10 being produced by the for loop, second answer 20 being produced by the second for loop. So far, so good, right? Then your boss, as you can imagine, very excited and says, why don't you add, yeah, you got it, 10 times of 3's, 10 times of 4's, 10 times of 5's. And now you're going to be sitting back and wondering if copying and pasting the for loops is really a bright idea. Because if your boss were to say, why don't you do that for, numbers ranging from 1 to 100? Beginning to see that, well, I may have to do some sort of repeated loops. All right. If the boss says 1, 2, 3, 4, 5, and so on, that means add up 10 times of 1, 10 times of 2. And you notice there's 1, 2, 3, 4, 5 in certain mathematical relationship. It's always plus 1, plus 1. Then it's easy. You can do a double for loop, as in for j in range 1 to 5. All right. So we're going to add up 1 one 10 times, 2 10 times, until 5 inclusively 10 times. And then we will repeat the loop inside, right? The summation loop inside. All right. And then mission accomplished, right? So let's do that and see. So nope, that's because I need to change the T plus to J, and we'll print a separator statement here. So now we can automatically compute this still without using any function. So far, so good. That's because we fortunately had data that exhibits certain mathematical relationships. So we could use a for j outside to wrap it. But even so, we would also possibly encounter situations where the numbers may be a bit haphazard. For example, your boss may ask you to add up 1 10 times and add up 7 10 times. That's all. Because COVID-19, right? The data is very unpredictable. So in that case, what should we do? We no longer can do the 4J and stuff like that because it's, you know, not really stepping through in a very systematic manner, mathematical manner. So what should we do? Well, we noticed that it would be nice if we can factor out this code, right? Because this code is really, the logic is the same, but just the constants, the numbers are different. So we can then do something like this. We're just going to print a separator again. And we say that why don't we factor this code out? This code, remember factoring, in high school algebra, we have y equals to x plus 2 x squared. And we know this x and x squared, we can factor out, take out one copy of the x and say x times 1 plus 2x. So that's factoring the algebraic variable out. Here is kind of similar, but I won't try to push it too far. But we are noticing that this structure seems to form the same backbone template all through for all our boss's varying requirements. Yeah, the logic is the same, even though what the boss is asking adding on to different numbers, the logic to do that is the same. It's like the cooking recipe is the same for different kinds of shapes of cookies that we are building, right? The whole sequence, baking, timing, amount of flour, egg, and so on are the same, you know, except we cut it in different shapes. So we could functionalize, if I can use the word, we can define a function by extracting out this common logic. So we do that by using DEF. So DEF is Python's reserved word, specifically reserved, defined for function definitions. That is, we define the function. We're not using it yet. We're just creating it. We're just writing out the recipe and that's all. We're not running it yet. So define a function. Here we get to use the creativity in terms of naming the function. So here we can say add them up, right? Maybe not the most creative name, but you get this choice of calling it meaningfully, right? Add them up. And what we can do is we can do this. I just copy and paste it. The total equals to 0 and the whole thing inside. And then print, even including printing out of the results. And that's it. Okay. Now, what does this do? This does nothing other than adding 2's 10 times.